Well, we're coming to the end of fall break, and I opened up my iPad, and this is what I saw. So I suppose I should upload this, which I'll do after I finish making this video. But first, I need to just talk about briefly the how to deal with the absolute maximum and minimum on a closed interval. Pretty much the same thing you've been doing, except it's actually a little bit easier. So the main deal is that we're going to be finding the critical numbers of your function, and then you're going to evaluate that function value for each critical number. But then you have to worry about the endpoints, and the reason that you have to worry about the endpoints as well is because when you're dealing with a function on a closed interval, you might have a situation like this. And let's just say that maybe A is right here and B is right here. And so in this case, the absolute minimum happens to be at the endpoint, even though that endpoint isn't technically a critical number, and the absolute maximum for this interval. So there is a relative maximum and a relative minimum at those 2 points, but the absolute max and min is there. This is sometimes called the candidates test. I like to think of it as you're going to just make a list and send it to your little brother or sister and ask them which is the biggest, which is the smallest. It's actually that simple. Okay, so let's do this with a couple of examples. I just have two for you, one easy, one hard. So the easy one first. So I want the absolute maximum and minimum for this function on this interval. And so the first thing we're going to do is we're going to find the critical numbers. To do that, we take just like before, take the derivative, 3x squared minus 6, set that derivative equal to 0, solve for x. So this is just like what you were doing before. So I have 3x squared is equal to 6, x squared is equal to 2, which means that x is equal to plus or minus the square root of 2. Now, just to save us from having to do too much work, we have this as our closed interval. And so it's like you don't care about anything that happens that's outside that interval. So in the case of this problem over here, the interval is from -1 to 3. And so if A is -1 and B is 3, if something happens, say down here, we don't really care about it. That purple tail, it doesn't exist in our minds because we're just looking at this window. It's like we've zoomed in and we don't see anything to the left of A. So let's take a look at this. In this case, the negative square root of 2 is to the left of the -1 there. If I was to draw a number line, which I'm about to do, I guess, you have -1 right here. 3 is over here. We only care about numbers in between those. Radical 2 is somewhere in between. But negative radical 2 happens to be over here. Negative radical 2, and so we don't care about it. Okay, so we've done the critical numbers. We've taken care of 1. Number 2, we're going to evaluate the function at each critical number that's in the range. So I always make a little table because it helps me to organize my thoughts. And f of x is conveniently right there. So I'm going to actually have to do the work now. So we have radical 2 cubed. A calculator would make this a lot easier, wouldn't it? Let's see, that is equal to, let's see, this is 2 radical 2 minus 6 radical 2 plus 2. So that's going to be 2 minus 4 radical 2. Let's just leave it like that for now. We can deal with the decimal, what that is as a decimal in a bit, but it's negative, whatever it is, because radical 2 is 1.414. So the 4 times that is going to be bigger than 2 for sure. So that'll be a negative number. So let's just shelve that for a sec. Next. We've done that, number 2. Number 3, evaluate f at each endpoint. Okay, so the endpoints, -1 and 3. These are relatively easy usually. So we're just going to plug these in. So this will be -1 cubed. On a calculator, it would make things a lot easier, I realize. There we go. So let's see, I think I can do most of this in my head. 8 minus 1 is 7. Okay. And then I'll plug 3 in. I get 3 cubed, that's 27. 6 times 3 is 18, plus 2. So let's see, 27 minus 18 is 9. 9 plus 2 is 11. Okay. So it actually doesn't matter that I don't know what 4 radical 2 is, because that's going to be the minimum. So the final answer is the minimum. You can do this on a calculator if you want to, but I'm just don't want to have to. So here's how I'm going to write this. The minimum value of f of x is 2 minus 4 radical 2. So this is the minimum value, and it occurs at x equals radical 2. And then we say that the maximum value, is, it turns out, 11 at x equals 3. And we're all done. Okay, let's take a look at a little bit harder problem. I was looking at your adfinity stuff, and I saw something, not like that, like this, and it scared me. And I thought I better do one for those of you who need the help with the trig functions. So let's go to it. So step 1 is find the critical numbers. And to do that, I need to do the derivative. So I'm going to do my derivative here. I should probably write this like, no, you're going to use the chain rule. Okay, so f prime of x is going to be 4 times the cosine of x. Okay, now let's deal with this chain rule. The derivative of cosine is negative sine. Don't mess with the inner function. So essentially what I'm doing here is I'm just ignoring this. Just going to leave it alone. Now multiply by the derivative of that thing. So times 2x, times derivative of 2x, which is 2. So to get from here to here, I use the chain rule. Okay, so I've got my derivative. I set the derivative equal to 0. Oh, let's make that a 4. And then we cry because we don't know what to do. No, we don't do that. We use some identities. So back in pre-calculus, you might remember doing this if you had pre-calculus here at UNC. If not, sometime in your past, maybe you did trig functions, trig equations, but here the identity I'm going to use is the double angle identity for sine. It's super useful. I'll write it down here. And like I said, I did preview your adfinity stuff, and I noticed this, that you might find this useful. The double angle for cosine, which is cosine squared x minus sine squared x. But this comes in 3 versions, and that first one is not the one that you're going to want to use. I can't remember which one you're going to use, but it's going to be one of these. You're going to pick based on the rest of the equation. I think it might be the third one, but one of those things. So just bear this in mind when you get to the adfinity so that you don't lose your mind, that you're going to use one of those identities. Okay, moving on. Let's see how we can get through this. So I'm going to use the purple identity right there. Cosine of x minus 4 times 2 sine of x times cosine of x. So you see how I've just made that change? That's pretty straightforward. And then now, let me clean this up, and then we're going to factor. I know, the algebra is the hard part, isn't it? Now we'll factor out 4 cosine of x. So far, so good, hopefully. Then you can say, okay, I know that cosine of x, either cosine of x equals 0 or 1 minus 2 sine of x equals 0. That bugs me. Let's get rid of that. So one of those two things will be true. Now, we just have to use our knowledge of the unit circle at this point. Here, I'll just do this really quick. This means that sine of x is 1/2. Okay, bear in mind that we're interested in angles between 0 and pi. Okay, so let's do these one at a time. The cosine of x is 0 at right angles. And so the solutions here will be anything that's a right angle. And the only right angle between 0 and pi is pi over 2. Going over here, I don't know what to tell you. You just got to figure it out. How are you going to know this? Get a unit circle. And this is going to be x is equal to pi over 6, and x is 5 pi over 6. I don't want to reteach the whole trig, how to know the angles and all that, but tell you what, you come visit me and I might be willing to give you a few pointers. So if you're really struggling with this, let me know. Okay, so there's those are my critical numbers, and those are all that, see, fortunately, we don't care about anything outside that range, 0 to pi, because each one of these, because the sine and cosine repeat themselves, there's many, many more critical numbers, but these are the only ones that are in the range that I'm interested in. So let's make a table. I love making tables. Start with x, and then f of x, and it's way off the screen, 4 sine of x, 2 cosine of 2x. Okay, so here's what we're going to put on our table. So just to review, you're going to put on the table critical numbers and endpoints. And then the smallest will be the minimum, the biggest will be the maximum. That last part is the one that you could give to your little brother or sister as long as you've evaluated the function correctly. Okay, so I'll do my critical numbers first. I have pi over 2, pi over 6, and 5 pi over 6. Those are the critical numbers that I got just a minute ago. And then the endpoints. So I'll just draw a little line, I guess. So these are critical numbers. And these are endpoints. 0 and pi. All right, let's do it. So I'll just write this out. 4 sine of pi over 2 plus 2 cosine of 2 times pi over 2. Oops. The sine of pi over 2 is 1. The cosine of pi is -1. 4 times sine pi over 6 plus 2 times cosine of 2 times pi over 6, which is pi over 3. So that'll be 4 times 1/2 plus 2 times 1/2, which is equal to 3. This will be 4 times sine of 5 pi over 6, which is 1/2, plus 2 times cosine of 2 times 5 pi over 6. That's 10 pi over 6, which is the same as 5 pi over 3. The cosine of 5 pi over 3 is positive 1/2. Yeah. Okay, so 4 times 1/2 plus 2 times 1/2, which is also 3. Okay, onward. Next we have 0, and that's easy, so this is going to be 4. Oh, come on. 4 times sine of 0 plus 2 times cosine of 2 times 0, which is, let's see, the sine of 0 is 0. The cosine of 0 is 1. So I'm just going to write that down as 2. And then 4 times the sine of pi plus 2 times the cosine of 2 pi. And there again, I believe we just get 2. Wow, this doesn't feel right to me. Let me double check some stuff. You know what? I feel like I should pause and double check my work before I post this. So I'm going to pause. I'll come right back. Okay, I'm back, and I had to do a little bit of investigation just to make sure that I was had the right stuff. But I do. So let's just talk about the answers, and then I'll show you the picture. I did graph this because I was worried, because I thought the graph was a little bit more exciting than this. This is kind of boring, to be honest. But let's write down the answers. So we have the maximum, or minimum. The minimum value is 2. You see it, it's right here. This is the smallest. Minimum, minimum, and minimum. At x equals 0, x equals pi over 2, and x equals pi. So the minimum happens 3 times, which is weird. I'll show you the picture momentarily. You can see it peeking out at the bottom. And then the maximum. This is the maximum. Here's the maximum. So the maximum value is 3 at x equals pi over 6 and x equals 5 pi over 6. Wow. Yeah, so it's just a little bit boring. Here's what the picture looks like of this particular function from 0 to pi. So you can see here's the end point and end point. So here's x equals 0, x equals pi. Here is x equals pi over 2. And then you can kind of see the maxima occur right there at a maximum of 3. And this is, I know the bottom is not labeled very well. This is x equals pi over 6. And right there, that happens to be x equals 5 pi over 6. I guess I was thinking that this was a more exciting graph, and if I had extended the range a little bit further, it would have been more exciting because you can see it dips down really far after this. So here's all we're really interested in is so here's pi right there. So from here to here. So that's the closed interval from 0 to pi. This is more interesting, but whatever. All right, that's it. Make sure you smash that like button and subscribe for more